This is a research paper that was published in Cancer Research. That's the name of the publication. And you can see here on the right some of the other videos that I have from Current Oncology, the Anti-Cancer Mechanisms of Cannabinoids by Manuel Guzman, and I don't know who else was on there, but it's definitely the Spanish team. So this research was conducted in 2008, but all of the data is still the same because we haven't moved from in vivo, which is the mouse models, into clinical trials or human models. So basically you can see here, same thing in every single paper or document. Ceramide goes up, stresses out the endoplasmic reticulum. Once the endoplasmic reticulum realizes that it's being stressed to the point of death, it induces autophagy, which is a cell's way of recycling itself. They call it suicide, cell suicide. And then once autophagy is completed, downstream of that within the cell is apoptosis. Apoptosis is programmed cell death. So one of the things I want to touch up on right here is the cell cycle arrest and the cell growth inhibition is what is called, or what would be deemed, anti-proliferation or anti-proliferative measures or activity of cannabinoids. So cell cycle arrest is whenever they stop the cells from dividing, ergo you don't get more cells than just the one that started to divide. Then the cell growth inhibition is whenever these cells do divide, if the ones have already divided. If you're able to stop the ones from dividing more, then you're lowering the cell growth of the tumor volume. And so you're inhibiting the volume of the tumor by stopping the cells from cycling into their next cell. And that's anti-proliferation or cell cycle arrest, and that leads to apoptosis, of course, because the cells will degrade and do the whole signaling towards self-suicide or self-death or whatever it's called, apoptosis, or autophagy, that's what it was. Auto means self, and phagy means to eat. So autophagy is whenever a cell basically breaks itself down to eat itself. And this happens anyway, normally, whenever a cell is stressed out. And apoptosis happens normally whenever a cell ages. So what cannabinoids are doing are just inducing this into the cells, or through the cannabinoid receptors into cancer cells. So what I like about this part right here is it talks about the agonists of cannabinoid receptors, or cannabinoid receptors expressed by tumor cells. An agonist, again, is an activator, and you can use any agonist, which would be an andamide on the inside. So what we're going to do is we're not hijacking an andamide or the endocannabinoid system. We're supplementing it with more troops. We're sending more troops that way to help the endocannabinoid system do its job whenever it comes to tumor regulation and metastasis. So I want to come down, you see the wording on the bottom of the graph, or on the bottom of the image, and this is what the words are. So this is a schematic representation of signaling pathways associated with cannabinoid receptor activation induced by its agonists. Again, agonist, pro. Antagonist, no. I guess you could put it that way. Upon receptor binding, cannabinoid receptor agonists inhibit cell proliferation and stimulation of ceramide, or upregulate, I should say, stimulation of ceramide, which leads to the subsequent induction of apoptosis. So again, induced cell death, apoptosis. Cannabinoid receptor agonists also activate modulation of cell cycle regulatory molecules, resulting in arrest and apoptosis. Those mechanisms are based on available literature and are cell-specific, and not all pathways are triggered simultaneously. Further studies are needed to unravel the detailed mechanism of action of cannabinoid receptor activation by their agonists. Good wording in there. So, of course, it says right there at the end, we need more research. That's clear. And whenever it talks about that not all of these pathways are activated immediately, so whenever autophagy happens, it starts activating, and then downstream from that, what they call it downstream within a cell, or the timeline chronologically downstream, so to speak. It's apoptosis, autophagy, then apoptosis. So I really like this graph, and I like the way that they worded everything. It's kind of complicated, but I enjoy it. So just wanted to share this with you guys. You got questions, of course, you can look this thing up or hit me up. I have a Facebook page, basically the same thing as this, Cannacare Project. So Cannacare, one word, project, next word. There is another page on there called the Cannacare Project, but Cannacare Project is where it's at. That's where I'm at, and yeah, enjoy watching the other videos that are coming out next. So thanks for watching this one, and share. Do share. Take a screenshot, and then you can show anybody you want to at any time. Share with your doctors, share with friends and politicians and other patients. 5 minutes. Word. All right. Holla.